Actually, I'm going to try to put a little bit different spin because I think we heard a lot about IoT today and how the platform can play a role. But I want to look at it from a bit different angle. So let's kind of go over a few things. So first, I want to thank our sponsors. Really, they were here to actually help us make this event today, and we will rely on their support for the next events too. So we heard these numbers before, and someone says by 2020 it's going to be 25 billion devices. Someone says 15. It's a huge number. That's what's important. Is it 15 or 25 or 35 billion? It's just one thing you need to remember. It's a huge number that's going to grow. Another thing that you need to remember is the potential economic impact is $3.6 billion. Sorry, $1 trillion. So that's a huge, and that's something that's very important. Another thing is 70% of this is a business-to-business use cases. Now, when I kind of present this, and you think from your angle, I might not be in IoT today, so how this actually applies to me? Am I late into this game? The answer is really no. There was a study done that basically says that 75% of companies are still in an early stage on kind of trying to understand really what the IoT is, how they can actually play the role, and how they can actually reinvent their company. Another thing is 55% of the company plan to invest 5% of their revenue to actually try to become an IoT company. So that's something that's kind of very important. And even though they're basically planning to invest a small portion of their revenue, they have huge expectation on their return on investments because they see the value of what's coming from their perspective. So when we talk about IoT challenges, we've seen some of those. It's from a business perspective, the competition is becoming stiffer. You have more and more players. We've seen where the small fish is eating, the big fish is eating small fishes, but then swarm of small fishes eat the big fish because the small fishes sometimes swim faster. And that's one of the things is that who's going to actually stay leader in this space really depends how aggressive and how innovative you are. Regulations and compliance. It's a fact that we're going to have more and more regulation and compliances. In some cases, that's a good news because right now, it's like Wild Wild West. There's different protocols, there are different laws and regulations. And if you think about it from, for example, different type of industry, in the automotive space, we're talking about autonomous cars a lot. But if you think, how would you actually drive autonomous car in Bosnia? Is it possible that you don't actually have a wheel, but someone is actually driving a car for you? So if you pass through the red light, what's going to happen? Who's going to be responsible? I'm not the driver. The car drove it. So in Bosnia, we probably haven't thought about that, but it's not surprised because even in the United States, they haven't. You do? Yeah. Okay. People watch the phone while they drive. Oh, okay, good. Yeah, you're right. But for example, California has the laws that you can actually have autonomous cars. But if that car crosses to Texas, there's no such law. And then you ask yourself the same question is, what's going to happen if you have the car accident? Who's responsible? I was at a conference last year in US. It's a World Congress, SAE Congress, and there was a panel discussions among the industry experts in automotive industry, US government regulators, and industry experts are basically asking government that they need to speed up because we're actually building this and we expect you that you're going to come up with the laws to support us. So Bosnia is light years behind, and we hope basically with this discussion to kind of start thinking about in that sense. Another thing is that from a technical perspective, I mean, there's a lot of technical questions that people need to think about it. We've seen in a number of presentations, different protocols. I think MQTT is probably one of the most advanced usages of the protocols for the IoT today. You saw the Microsoft platform, Oracle platform, IBM, Bluemix platform is also utilizing MQTT. So I think that's the beauty of the MQTT is you can actually embed the other protocols and basically use it as a payload. So I think that's one of the advantages. The open environment. So everyone is now playing with everyone. You saw the slide from Mark where actually they're using, they're basically open player and they have IBM DB2, IBM WebSphere platform. So same thing is from IBM, is basically we're opening that people can actually use our services on Azure. It's the same thing as we actually don't see each other anymore as competitors, even though sometimes people kind of see us in that way. Now, what I want to actually say is now, this is basically, these are the challenges when you're building the IoT. But let's take a step back. How about devices that exist today? Devices that you might actually purchase. So what happens is a lot of devices are built with some software capabilities. If you drive a car that's 6, 7 years old, probably that car has a lot of software in it. They probably have at least one computer. Perhaps they are not IoT enabled today, but they could be with very small investments. It's the same thing as with washing machines and so on. So you have that technology that you probably are part of it today, building your solutions, where you invest and build a solution. But the question is now, how do I take actually that device and bring it now to the IoT world? Number one is we talked a lot about sensors. In most cases, these devices already have sensors. And the only thing what you need to do is basically figure out how can I actually connect these devices to the internet. And there is basically a connection. It could be a wireless connection, actually could be a wired connection. But the key is that you have a connection, and then that connection leads you to most likely some of the IoT platforms that exist today. You don't want to go through the process of inventing your own platform. And then what happens is you have built a product, you sold the product, and once you sold the product, you never hear from a consumer unless there's an issue. So that sometimes it's good, sometimes not good. But it basically means is that consumer will be unhappy when the product doesn't work. What you want to actually do is kind of prevent those failures, or at least know that there's something going on. Let's think of it from a perspective of IBM has a commercial of the elevator. And we have partnered with Kone, manufacturer of the elevators. And what happens is in that case is they started building their solutions with our software years ago, but they were not IoT enabled. They had a brilliant idea is how can I actually connect these elevators, provide me a data, what's going on, and now actually I can share this information back to my engineering and try to learn from this information, because it's an easy way to basically build a solution with your test data. But when we take those products into real life, we always know that we use them differently than people imagine. So that's why the real test is really when customers and users actually start using those products, and we have ability to send this information back to the engineering. And that the information then can have rules that kind of triggers some alerts, triggers some specific activities, services. So in a Kone commercial example, what they have done is they have a technician dispatch to the elevator, and basically he's coming to the lobby and asked the security guy to let him to take a look at the elevator. And the Security guard says, well, our elevator is working fine, as you can see. Yes, but according to my instruments, in 20x hours, your elevator will stop working, and you might actually have people trapped in it. So that's why I'm here to actually fix it. So that's really the customer service, what you expect. And then when you talk about customer services, is you're delighted because, hey, you fixed something before it even broke. And that's what you want to do. Another thing you have to look at from an economical perspective. When you have to fix something, most cases you have to dispatch service representative to inspect, to try to figure out what's going on. He might actually say it's a part X. They order part X. He needs to come back the second time, replace it, and then it might not be actually working. So it's a multiple trips and that cost in addition to unhappy customer. So that's why the key is that you have a platform that has a closed loop. Platform that you used your traditional way to build a software, keeping your engineering practices that you currently have, and now expand it and IoTize it. You add your IoT layer that you send information back to your engineering, send alerts when there's something from a service perspective, or any type of alerts that actually can provide some benefits and a cost saving. So since we are kind of short in a time, what I'm going to do next is I'm going to actually run a nice video that kind of shows you in practice a video how the IoT platform can run, and you can get the benefit of a closed loop system. Now this is something, seems like it's a trend that we have videos today, so I needed to have something similar. Now let's see if that's going to work. Perfect.
JK Enterprises' automotive division have launched their new range of vehicles. Those vehicles come fully equipped with advanced driver assistance systems, or ADAS, including adaptive cruise control, lane assist, automated overtaking, blindside notification, and even off and on ramping. Historically, when the company sold products like these, that would be the last that they heard of them. They wouldn't have any visibility into how they were being used. But these are connected cars, and engineering has used modern cross-discipline systems engineering, underpinned by IBM's continuous engineering solution, to design the new ADAS features with connectivity in mind. Live data from the vehicles connected to the IBM Watson Internet of Things platform allows the company to monitor the adoption, usage, and performance of the new systems. That allows the business to preempt and even predict failures, helping to avoid costly warranties and call-outs. This direct feedback will also drive engineering, helping the company to rapidly respond to customers and competition in new ways. Let's see how JK Enterprises uses their advanced IBM-powered solution to stay ahead and keep the customer and stockholders happy. Specific sensors on the vehicle are being monitored by the IoT for Automotive platform against key performance indicators and expected usage patterns. Advanced Watson predictive analytics detects a deviation from those expected usage patterns. Here on the team's task management dashboard, an alert is raised that such a deviation has been detected. The engineering manager begins an investigation. Initial analysis shows that although the new systems are generally meeting expected usage patterns, in certain regions they're being underutilized. Watson Cognitive Analytics reveals a correlation between the state of the roads in those areas and the weather conditions at the time. The company performs a directed survey, and Watson analysis on the results reveals that there are two issues. Firstly, in these specific conditions, users are experiencing an uncomfortable ride when the adaptive cruise control system kicks in. Secondly, when visibility is poor, users are switching the system off altogether. They simply don't trust that the car can see any better than they can. The engineering team now investigates the original system requirements for the braking system. Using impact analysis, they quickly reveal linked designs and test data. They also find that the design team had already identified a risk with the sensitivity of the braking algorithm, and work was already in the plan to address it. The plan is updated to give it a higher priority. New requirements are also added to overcome the issue of confidence in the system's capabilities in poor weather conditions. New and updated requirements can be connected to the design elements of the IoT solution. These connections help understand the impact of the gap between the as-is and the to-be design, and guide engineers and developers to focus limited and expensive resources on doing the right things the right way. Requirements management clarifies the gap between what your current IoT solution provides and what your customers might need. The design team explores the existing design and employs trade studies and simulations to investigate and compare the alternative ways to improve customer confidence in the ADAS systems, allowing the business to select the most optimal solution. Based on this analysis, the team come up with an innovative idea. The center console and heads-up display will be updated to display a visual indication of where other vehicles are. This can be switched on manually at any time, but will come on automatically when visibility is poor. Requirements may be allocated and traced to different parts of the system, whether those parts are virtual cloud-based applications in Bluemix or cognitive software running on devices connected to the IBM Watson Internet of Things platform. This is essential for efficient development of IoT systems, where the functionality of the application as a whole is often spread across several different platforms. Defining and maintaining the interfaces between those platforms is critical. The team use a lean, scalable, agile development process to plan, implement and track the work. New plan items are linked to the requirements they implement, as well as the designs, including device firmware, IoT platform rules, web and mobile applications. New test cases are also created and linked. An automated test management and execution framework allows the teams to automatically execute and collect the results of tests created on the Watson Internet of Things platform. A continuous delivery pipeline builds and validates each of the solution components, alerting the team quickly when there are any regressions, improving quality and productivity. This allows engineering to verify that the work that was done meets its intended requirements. So what have we seen? JK Enterprises used IBM Internet of Things and Watson Analytics to detect potential issues that would have been all but impossible to identify before the product was actually in use, and continuous engineering to enact fixes and improvements to the product. After focused quality testing, the vehicles are updated over the air, so customers gain the benefit of their improved functionality without the inconvenience of taking their vehicle back to the dealer. Consumer feedback and usage data confirmed the solution. More drivers were now using the advanced systems in bad weather, resulting in safer roads, something the marketing team could use immediately, and allowing the company to make a more informed decision on whether to make some of those features available to their mid-range cars. Consumers get a better product, and the company gets closer to its customers than it ever could before.
I want to stop here. Okay. So that's what I wanted to show you, is basically how you can actually take your existing product, tie it to your IoT, and help you basically do a cost savings or the run of the project. So what you have seen is you use your engineering practices, hopefully that you are practicing today. If not, let me know and we can talk about it. But really the key is if you're working in an industry that is life saving, like medical industry, automotive industry, what you need to basically do is always keep in mind is if something happens, you need to prove what happened, why it happened, and when it happened, and why basically this was not covered. So automotive industry is very kind of keen to, when there's a death, that they can actually trace why that happened, and hopefully that's not related to something with their specific cars. And if it does, they need to trace it basically, not just from the car, they need to trace it to the requirement that actually started the entire process. So the engineering process, continuous engineering, provides you a linking from your requirements to your implementation, to your test cases, to your operation side. And now we're also adding the IoT, where you're actually adding the data from your production and feeding that to your engineering practice. So with that, I will stop since we have a couple minutes to see if there are any questions, and we have a 6:45 that we're gonna continue with the video call to Naborsha, so that's why we need to be on a time. Any questions? No? Thank you.